Hello, my name is Bob Smith, and this tutorial is about producing the files you need for CLUZ and Marxan. This follows on directly from the tutorial 1 video, which provided background information on systematic conservation planning and then showed how to use CLUZ and Marxan to identify priority areas for conservation. This video shows you how to make the files that were used in tutorial 1, and I recommend watching that video first. So in this tutorial I'm going to show you how to create the CLUZ files, setting up CLUZ, updating the status of the planning units, and adding abundance data and updating the target table. CLUZ is a plugin for QGIS, both of which are free, and so is Marxan. So everything that I'll show you today is open source free software. For this tutorial you'll need to download the CLUZ ex2 zip file from the CLUZ website, which is there. In this tutorial we won't be using Marxan, we'll just be looking at how to create the files for Marxan, but the link for Marxan is there, and I strongly recommend signing up to the CLUZ mailing list so you can hear about the latest versions of CLUZ and any new tutorials. So for this tutorial, the first thing you'll need to do is download the zip file from the CLUZ website for tutorial 2. So here it is here. I'm going to right click and say extract all. And that's created a folder called CLUZ ex2, which contains all the information that you'll need for this tutorial. So all the shape files, but all the other files too. So now I'm going to go to QGIS, and as you can see, I've already installed the CLUZ plugin. If you haven't done that yet, you'll need to go to the plugin menu, manage install plugins, and choose CLUZ there from the list. But as I said, I've already done that. So you can see there's the CLUZ menu there, and also the CLUZ buttons here. So I'm going to start off by showing the layers that we use to produce the planning unit layer. So these are two shape files, one of which is called nature reserve and one of which is called hexagons. So of the two layers, the nature reserve just shows the boundary of the protected area that we're going to use in this analysis, and this will be set as conserved in the analysis. This is the land that's already protected. But I've also produced a layer called hexagons, and this was produced by going to the vector menu, choosing research tools and create grid. And using this we produced a series of hexagons that are 25 hectares in size. So that layer shows those hexagons, and we've also clipped it to our planning region. So to combine those boundaries with the protected area boundaries, I then, in the vector menu and geoprocessing tools, use the union option. So I unioned those two layers together. And the result is shown here. So this is the shapefile called planning units. This is the final shapefile that we'll use in this analysis. So I'm going to remove the other two. And you can see from this, there's all the hexagon boundaries, but if we zoom in here to the boundary of the designated area, you can see that there's a whole set of whole hexagons, like this, which I'm selecting here. But at the boundary of the protected area, we've got sections of fragments. So the reason for doing this is that in Marxan, a planning unit can only have one status. So if we want to precisely specify where the protected area is, where the conserved area is, then we need to make sure that its boundaries represented by the planning units. So that's why we've done that. So by doing the union, you also create quite a few small planning units, these little fragments here. And that's fine. But you might decide that you want to get rid of those small fragments. And the way to do that is to highlight them using the field calculator, and then you can open the toolbox, and if you search for eliminate, there's the option of eliminate selected polygons, and that lets you merge the tiny fragments with the ones that neighbour them. So we now have our planning units. But if we look at the attribute table, at the moment there are two fields. There's one called name, which is mostly blank, apart from the ones that show the name of the protected area, and also there's a field called region, which has got the number 7 there because we've arbitrarily said that this is in region 7. But to turn this into a CLUZ file, we need to add a few more fields. But there's an option in CLUZ to do that automatically and create the other files that you need. So I'm going to go up to the CLUZ menu and I'm going to choose Create Initial CLUZ Files. So that asks me first of all to specify the name of the planning unit shapefile, which is called planning units, and it's asking for an area conversion factor. Well, at the moment everything is measured in meters, so it would calculate areas in square meters. That's not very helpful for me. So to convert everything into hectares, I'm going to say divide the values by 10,000. I'll also set the cost layer as equal to the planning unit layer. And now it's asking me where it wants to save two of the other CLUZ files. So one of them is the puvspr2.dat file that Marxan uses. And I'm going to say that that should be saved in the input folder. And I also need to specify where to put the CLUZ target table. And I'm going to put that directly into the CLUZ exercise 2 folder. And I'm going to call it targets.csv and click on save. And I'm going to click on OK. So CLUZ is now telling me that it's created the blank files that I need to use to set up CLUZ and then run Marxan. So now I'm going to create the CLUZ setup file, which specifies where all the CLUZ and Marxan files are found. So I'll go to the CLUZ menu, choose the first option of View and Edit CLUZ setup file, and go through the same process that we did from tutorial 1. First of all, by specifying where Marxan is, which I've saved onto my C drive there. Then for this tutorial, I'm telling it that the input folder is there. The output folder is also in the CLUZ exercise 2 folder. I have my planning unit layer. And also my target file. And I'm going to specify that all of these should have 3 decimal places. And I'm going to save the CLUZ file in the exercise 2 folder. I'm going to call it exercise 2, ex2, and click on save. And now I can close the setup file. So you can see from this that now CLUZ has automatically formatted the files in the right way. So I can remove the first version of the planning unit layer, remove there. So we have our planning units here. So these are the same hexagons and fragments of hexagons from before, but now they're all shaded green because they're available for conservation. If I go to the target table, I can see there's the target table, but at the moment it's blank. It doesn't contain any data. And if I go to the abundance table, I can also see that at the moment it doesn't contain any information. And finally, if I go to the folder itself and look at the input file, you can see that CLUZ has created a blank puvspr2.dat file for use by Marxan. If I open it there, again you can see that at the moment it's blank. It's just got the headings of the columns. And so what we're going to do in a little while is add that data. But before that, I'm going to change the planning unit status. So I'm going to specify for each planning unit whether it's available, earmarked, conserved, or excluded. At the moment, everything's in this pale green, which means that it's available, which means it could be selected for meeting our targets. It could be selected for future conservation. But of the 3 other choices, a planning unit can be excluded, which means that it's never selected by Marxan. It could be conserved, which means it's always selected by Marxan. Or it can be earmarked, which is a status used in CLUZ to identify which planning units are earmarked for conservation. So which ones would you like to add to the existing protected areas? And the next step is to set which are the excluded planning units. So in this tutorial, we want to identify a set of planning units that are found near 2 growth points. So these are 2 areas that have been identified as where new housing should be created. So I'm going to bring up that layer. And here they are now. So here are where the 2 points are. what we're going to do is identify planning units around those 2 growth points that we'll set as excluded. So I'm going to go up to the vector menu and geoprocessing tools and buffer, and I'm going to set that I want to identify a buffer of 2,000 meters around each one of those growth points. I'm going to click on run, and there they are. There are the 2 growth points there. So now I'm going to go to vector and research tools and select by location. And what I want to do is add features from the planning units that are within the buffers. And again, I'm going to click on run. So if I turn off the buffer and the growth point, you can now see that there are a set of planning units that have been selected by QGIS because they're within 200 meters of the growth points. So to change their status, I'm going to go up to the change status panel. Now normally when you run this, CLUZ is set up that you can just adjust whether a planning unit is available or earmarked. But in this case, because we're right at the beginning, we want to specify that those planning units should be set as excluded. So I'm going to choose that button there and click on change. And their color has been changed to dark purple to show that they're excluded. And the next step is now to identify the planning units that should be conserved. So I'm going to go and open the attribute table of the planning unit file. And I'm going to go here and say select features using an expression. I'm going to go to the field called name and look at all the unique values. And we can see here that there's a value called Itemba. So Itemba is the name of the protected area. So I'm going to say equals, and then double click on Itemba and say select features. And then close here and the attribute table, and we can come back to the main view and see that QGIS has selected these planning units here because that's where the protected area is. So again, I'm going to go to the change status panel, again say allow changes to conserved and excluded status, and we're going to set these as conserved and click change. And if we close this, this now looks identical to the planning unit layer that you used in the first tutorial. And we're now ready to add our conservation feature data. So this is the species, habitat types, whatever we think is important. We import that data into CLUZ and then use it to run Marxan. So the different layers that are used in this exercise, the first one is the land cover layer, and this is a raster data set. So I've selected that I want to add a raster here, and I'm going to go through and choose the land cover layer, which is here in this format, a GPKG file. So I've added that on top. You can see here that there are values from 1 to 33. So each of the different land cover types has got a different value. And I'm going to go to the CLUZ menu and say convert raster to Marxan abundance data. Because I've added it to the view, it appears here, so I can select it. Again, because everything will be measured in square meters unless I tell CLUZ to measure it in different ways. So I want to convert this into hectares by divided by 10,000. And I'm going to click on OK. And CLUZ has now imported that data. So I can tell this because if I go up to the target table button, I can now see the target table. So all this information is blank, but it showed me that it's imported these different conservation features with these different ID values. And it's showing me the area that's earmarked and conserved and the total area here. So that's worked well. So now I'm going to add some species distribution layers, which in this case is 2 cycad species. So cycad's a plant species, and you can see that there are 3 polygons here showing their distribution. If I open their attribute table, you can see that there's actually 2 species there, F splendens, and A gigantica. And the key thing here is that I have a field called ID, and this gives the unique ID value that I want to give for these species. So this can't overlap with any of the other conservation features, and the number has got to be the same for the same species. And again, I'm going to go to the CLUZ menu, but this time I'm going to say convert polyline or polygon theme to Marxan abundance data. Because the layer is showing in the view, it appears here. Here it's already specified that the name of the field that contains the ID is called ID. And again, I want to convert this into hectares by dividing all the values by 10,000. So CLUZ has imported that data again, which I can see again by going up to the target table, scrolling down, and you can now see that there are records for species with an ID of 105 and 107. And the final data I want to show you how to import is from a text file. So this describes the number of vulture nests there are per planning unit. We can actually look at that data here, the raw data. There's the nest data here. And this lists all the planning units, and also for the feature, which in this case we're giving it an ID of 156. So each field has got to have that ID number at the beginning of it. It also needs a letter character at the name of the field name, because QGIS can't recognize field names unless they've got a non-numeric character at the beginning. So this is a really helpful format to import, because you can use lots of other GIS functions to calculate the amount of the different feature in the different planning unit and bring the data in that way. So again, coming back to CLUZ, I'm going to say that I want to import fields from table to Marxan abundance file. I'm going to find that CSV file. There's the nest data. Specify that the unit ID field name from that file is unit ID. And in this case, we don't want to do any conversion because the numbers represent the number of vulture nests. So I'm going to click on OK. And again, CLUZ has imported that file. So when I go to the target table and scroll down at the bottom, I can see there's now a new value for feature 156, which is showing me that there are 34 vulture nests in total in all those planning units. So I've imported that data. We have the values in there, but at the moment we don't have any details on the name of the features or what the target should be or anything like that. So to do that and to cheat, I've actually got that information already in a separate Excel file, which I've typed in there, and I'm just going to copy that over into the target table. So the target table, as I said, is this targets.csv file, which at the moment has got these blank values. So I'm going to copy all of those over. Into here. So I haven't edited the ID values, those are the same, but I've specified the name, what type they belong to, what the target should be, and the species penalty factor. These other three fields are the ones that are created by CLUZ. Now you can see at the moment the PC target is -1 because beforehand we didn't have any target set. But if I save this file and close it, and now open it in CLUZ, you can see that that information is showing in terms of the name of the feature and the other details, but it's also automatically calculated how much of the target has been met. So based on the target of 244 hectares, but at the moment none is protected, so it's showing us that the percentage target is 0. Now with this extra information, I can also go to the abundance table, and it will show me here the details, so I can look at, for example, how much montane aquatic there is in each planning unit, and it will bring up the information there. And similarly, I can look at the distribution of different features, so if I want to see where the montane aquatic is found, here's the layer there. So in fact, yeah, let me remove the SciCAD layer. And you can see there's the montane aquatic layer there. So I've shown you in this tutorial how to produce the files that you need to run Marxan. I've showed you how to create the planning units from scratch, make the other CLUZ files, and then import the abundance data. So you'd now be ready to use Marxan to use this data to identify the best places to create new conservation areas to meet your targets.